This video will be talking about how we take parabolas and how with the information we know about graphing parabolas and how do we transition into now what if we don't have the graph and we want to know, just given an equation, how do we solve it? And so the idea is what we're trying to find if we had the graph, if we had a parabola, what we're trying to find are the points where our graph cross the x-axis. Okay, so here it would be at the point at 1, 2, 3, 4. Here the point at 4 where x is 4 and y is 0. All right, so it's always going to be where y is 0, 1, 2, 3, 4, 5. Or here at the point of -5 and then 0. Okay, so we kind of have each graph there. So to start this process, what we're actually going to do is we're going to say what, kind of looking at when we looked at when something was in x-intercept form, all right? When it was x-intercept form, it kind of looked like this, all right? So we're going to just look at the one part of it. And so what we're going to actually do is we're going to say, how can we put everything into x-intercept form? Because that's what we were just saying. Hey, it really matters where the intercepts is. So no matter what form we're given, how do we kind of manipulate it and put it into x-intercept form? How do we always get it into this form so we could quickly, without a graph, say, oh, I could quickly figure out where my axis is. So this answer in x-intercept form would have been x plus 5 and x minus 4. And so we could have seen that what makes these x's a 0 is a -5 and a +4. Kind of our solutions here. So it kind of helps us to know those. So we're going to say, how can we always put it into x-intercept form? So what we want to talk about is how do we get it into x-intercept form is kind of how do we undo it. So we're kind of doing it backwards and then we're going to do it forward. So we're kind of saying, okay, before we knew when we had an equation like this, or we had, let's just say we had this problem right here, and we were asked to multiply. When we were asked to multiply, what we would do here is I would kind of take my first value, my x, and I'd multiply it by the x plus the 3. And then I'd take my second value, my 5 here, and I'd multiply that by the x plus the 3. All right, so in this case, I do distributive property. I'd get x squared plus 3x. In this case, I do distributive property again. I'd get 5x plus 15. Almost always you can combine your middle two terms. And so when I did that here, I got 8x and then plus 5 and then x squared. Hopefully you did a lot of this in Algebra 1, in high school algebra. What we also have learned is there's a quick way to do this, okay? So even here, when we're talking about all of this, here we figured out we have a word that kind of reminds us of our orders here, and it's called FOIL. And the idea is when we had our original problem here, I'm going to go back to my original problem. The first two problems, the first values in each of the groupings was the f, and when I multiplied those together, I got the first value. The outside values here, here's my outside values. The outside two values, the x and the 3, is how I got the 3x. These two were considered the inside values, and that's how I got my 5x. And then the last two values, I'm going to put an L by those, were how I got the 15. I don't know where I missed my 15 there somehow. How I got a 15. All right. So it's kind of how we do the FOIL. And so we're actually going to be working a lot of how can we reduce FOIL, reverse FOIL. How can we take something like this and make it look like what we had in our original problem. But first we want to talk about how do we do this FOIL and what the FOIL looks like for different values. So let's talk about when we had an original problem, and if we kind of work backwards, when we had a positive here and a positive here, we got positives in our original grouping. When we had a negative in our original grouping and a positive, let's go ahead and do the FOIL here. The first would be x squared. All right, the outside would be positive 6x, the inside would be negative 3x, and the last would be negative 18. All right, so when I combine them, my middle two terms, I got a positive 3x. Now, so what happens here is if the last term here is negative, you're going to have one of each, a positive and a negative. And this depends on which is higher. All right, so if one of your values is higher, you're going to have a positive here. If the negative value is higher, you're going to have a negative there. So now let's look at this one. What happens when we start with two negatives? Now our first is x squared. Our outside is negative 8x, our inside is negative 1x, and our last is positive 8, positive 8 just alone. Inside would be negative 9x, we have plus 8, x squared. So we kind of work on this a little bit when we're in class, and we say, okay, how can we do a bunch of these? Here, outside, outside, inside, and last. Now what happens here is the outside and the inside equal a 0, okay? And so that's what happens over and over again, is that outside and the inside equals 0. So now we're going to talk about, okay, how can we just do some general factoring, all right? And we're going to just talk about this idea of factoring. So what we're looking at here is how can we factor? So we have a problem of 6x squared y cubed z and 24x to the 5th y to the 7th. First of all, let's talk about this concept of factoring. Factoring is basically what can I divide both terms by, and terms are separated by addition sign, both of these terms by, where they both divide equally or cleanly, and it divides both. So if I looked at just the 6 and the 24, the highest number that divides both 6 and 24 is actually 6, okay? So actually we have here our 6. The x squared, the highest number that divides x squared and x to the 5th is x squared. I could not take an x to the 3rd out of an x squared. I can only, the highest number I can take is 2 x's out of there. For the y's, I'm comparing 3 y's here and 7 y's here. The most y's I can take away is 3 y's. The z's, since there are no z's here, I can't divide by z's, all right, because it has to be able to divide both terms. So technically what I'm saying is I can factor out or divide out 6x squared y to the 3rd, and what I would have left, this would, and now it's kind of like I do the division in my head. These would all be 1, and so it would be 1z or just z. Here 24 divided by 6 would be 3, okay? 4. Gosh, gotta do my division correctly. 4. X to the 5th divided by x squared is x to the 3rd. Y to the 7th divided by y to the 3rd. Again, subtraction. Y to the 4th. So this is the problem factored. I factored out 6x squared y to the 3rd. Let's do another example. So now we're getting to a problem where it's in a quadratic form. Quadratics kind of have their own way of factoring. So we do some practice with non-quadratics where you can factor out a single term. Now we're going to work on quadratics. Quadratics means we have something to the x squared and something to an x. All right, it's kind of like ax squared minus bx plus c is kind of the standard. So something x squared plus something else times x plus a constant, not times a variable at all. So what I'm doing is I'm asking myself, if I did a FOIL and I had the first two multiplied together and the last two multiplied together on the outside and the inside, what numbers would be there so I can get x squared minus 13x plus 36? Where I start is, okay, in the FOIL, I'm kind of doing a reverse FOIL here, but I know that whatever in my first two values, when I multiply them together, I get an x squared for an answer. What two numbers, when I multiply them together, two values, do I get x squared? Well, only here, x times x gives me x squared when I multiply them together. So there's my first. All right. Next thing I think about is I think about what values, when I multiply them together, would give me my last. All right. And I'll show you in a minute why I think this way next. So I go last in my head. Well, there's a bunch. All right. I could do a 6 and a 6. I could do, what if I divided by 2? I'd get 18 and 2. I could do 2 and 18. I could do 9 and 4. I don't think I'm done. I could do 4 and 9. Wow, there are a lot of different combinations there that I could be doing. I could do 3 and 13. Wow, there is a lot. But what I have to look at is I have to look at all of these different options and say, what two options, if I put them in here, and when I look at outside plus inside, I'm going to get 13 for an answer. So I'm looking at which of these pairs of numbers, when I either add or subtract them, could I get 13 for an answer? All right. And when I'm going through, so I'm going in my head, 6 plus 6 is 12, and 6 minus 6 is 0. That doesn't work. 18 plus 2 is 20, and 18 minus 2 is 16. That doesn't work. Same thing here. Doesn't work. Hey, 9 plus 4 is 13. So that would work if they were both the same sign. So if they were both negatives, it would work. So actually, that's kind of how I go in my head, and I say, well, a negative 9 and a negative 4. When they multiply together, they give me a positive 36. But when they add together, they give me a negative 13. So my process here is I say to myself, what multiplies to get me the constant? But the same two numbers, when I add them or subtract them, I get the negative 13. And usually it's add them. You can think of them as adding them because you're really adding two negatives. Let's do another example, and hopefully it'll become a little bit more clear. I'm going to add one in here. Okay, so I'm factoring this. I'm going to ask myself, what two numbers, okay, first of all, I'll just give you this hint. Whenever you start with an x squared, you always know it's going to be x and x. You do. That's always what it's going to be. X squared alone, not a number in front of it. It's going to be an x and an x when we're factoring. So now I have to go out to my head, and I'm thinking to myself, what two numbers multiply to get 12, and the same two numbers, when I add them, I get a 7. Okay? So you kind of think in your head, and it's like a puzzle at this point. What works is a 3 and a 4. 3 times 4 is 12, but 3 plus 4 is 7. So both of them were positive. So that's where we got the 3 and the 4. And hopefully you've done some factoring before, because you should do some. So now we come up with the problem of what do we do when we don't have 3 terms, but it still kind of looks quadratic? All right, so we have an x squared and we have a constant. We just don't have the x. Well, my answer is add it in. You can always add in a term by adding a 0. Adding a 0 really doesn't add a value. So adding 0 times x really doesn't add a value. So now we can say, okay, I know it's going to look like this. And I just have to say to myself off to the side, what two numbers, sorry, I usually do multiplication first. When I multiply them, I get a negative 16. But when I add them, I get 0. Well, usually what happens here, when you have them and they're adding to 0, it's going to have to be a positive and a negative of the exact same number. And so in this case, it has to be a positive and a negative 4. And then here we had a positive and a negative 4. All right, so those were our values. So what we know, again, it had to be x, and it had to be a minus 4 and a positive 4. All right, that's actually called the difference of two squares. And actually, when you first have what's called a binomial, which was what we had up here, which was 2 terms, you should kind of be thinking to yourself, 2 terms, I wonder if it's a difference of 2 squares. I wonder if each one of these has a square root. Because if you notice, the square root of the x is here, and the square root of the 16 is here, and we just have plus 1 and minus 1. So let's see if that works in this example. Oh, I went too far. Sorry, I went in the wrong direction. Here we go. This example, 25x squared minus 16. Does this have a square root? Yes, it does. Does this have a square root? Yes, it does. So the trick here is this square root is 5x, and this square root is 4. And so it's really, the answer here is 5x plus 4 and 5x minus 4. It does not matter what order. I could have just as easily said 5x minus 4 times 5x plus 4. It doesn't matter the order you have it. But this is the factored value. I showed you that. Let's do this one. So now we have, what happens when we have a leading coefficient that's not an x squared? Boy, it gets a lot harder when that happens. Because if it's an x squared, it goes pretty easily. If it's not an x squared, you have a couple options. The first option is to be a little stubborn and say, okay, I'm going to get good, and I'm going to just try to guess as far as my puzzle goes. All right? And let me show you how I think of this. So what I do is I say, what two values multiply together to give me 2x squared? And really, it can only be 2x times 1x. That's the only two values that I can multiply together and get 2x squared. All right, so I did that. Ooh, I did want to do that part. Sorry. So now we get rid of this. So that's what gives me the 2x squared. Now I have to say what two values give me the 4. And actually at this point, I guess and check. I just throw one in there and I say, okay, if it doesn't work, I'm going to erase it and I'm going to do it again. So I call this kind of like puzzle erasing here. So the first thing I would guess and check is I would guess and check 2 and 2. And so now what I'm checking is I'm checking, does the outside plus the inside add up to 9x? The outside would be 4x. The inside would be 2x. Is there anywhere 4x and 2x adds up to 9x? No, no, it doesn't. So then I'd say, okay, well, I guessed wrong, so I'm going to guess another thing. So I'd guess another one. And this time I might guess 4 and 1. So now my outside and my inside. My inside is 4x. My outside is 2x. I'm still at 6x there. I'm not quite at my 9x. Don't think that this is your only option. This is different than this. Now, when we had the 2's, it didn't help me much to switch them because 2 and switched is still 2 and 2. But when we have the 1 and the 4, it does make a difference. There could be very different things here. So now what I have here is the inside is 1x. The outside is 8x. Hey, 1x plus 8x does equal the 9x. So if this is positive and this is positive, all right, my final answer here was that 2x plus 1 times 1x plus 4 can be factored or multiplied. It's the factor of the 2x squared, the original problem, plus 9x plus 4. All right, that takes a while, and I'm going to show you another option to do the same problem or a similar problem. Let me give you a similar problem. So another option I have is to use a formula called the quadratic formula. All right, and I'm actually going to pause it now and we'll get back to how to do the quadratic formula in another video.